In this example, we try to evaluate the integral of 2x plus 1 times x squared plus x plus 1 to the third dx. So you might say, hey, I want to do algebra and I want to just raise this guy to the third power and then multiply by 2x plus 1. There is a better way to calculate this integral, which is using substitution. In using substitution, the quantity inside the parentheses with higher exponent, which is 3 here, can be used for your u. So you're introducing a new variable like u, and you're saying that, hey, I have x squared plus x plus 1, and when I take the differential, let me use a different color. When you take the differential, du is 2x plus 1 into parentheses dx. Very good. Do you have 2x plus 1 dx? Yes, I can just recognize it here. This is my du. So this integral can be written as the integral of, so again, this guy is du, and the quantity in red is u, so you have u to power 3 du. From this integral in x squared plus x plus 1 to a much simpler integral, which is u to the third du. This is a familiar integral. We have seen this before. If you have the integral of u to power n du, it is u to power n plus 1 divided by n plus 1 plus constant of integration. So this integral can be written as u to power 3 plus 1 divided by 3 plus 1 plus constant of integration, or u to the fourth divided by 4 plus c. Are we done yet? No, not yet, because our u is x squared plus x plus 1, and our original integral was written in x. So you need to do the substitution back. This guy becomes x squared plus x plus 1 to the fourth divided by 4 plus constant of integration. Sometimes the students ask, how do we know everything is correct? Well, you can check your work. To check your work, you can basically take the derivative of the quantity on the right-hand side and show that it is indeed equals to the original integral, which was 2x plus 1 times x squared plus x plus 1 to the third dx. So let us check our work. The quantity that we have is x squared plus x plus 1 to the fourth divided by 4 plus c. So if I take the derivative of this, it is equal to, you have the derivative of x squared plus x plus 1 to the fourth divided by 4, and the derivative of c is just 0. So remember that to calculate the derivative, the quantity, you have to use the chain rule. In using the chain rule, the quantity inside the parentheses is x squared plus x plus 1. So if you take the derivative of x squared plus x plus 1 and then apply the power rule here, you get 4 x squared plus x plus 1 to 4 minus 1, or 3. But take a look. This is equal to, and then I need to write down 4 on the denominator because I have it over there. So you have 2x plus 1 times, if you cancel out 4 and 4, x squared plus x plus 1 to power 3, which is exactly what was inside my integral originally. These two are exactly the same quantity. So it means that my integral was correct. So we use the substitution method to calculate this integral. We can also check the work. On the exam, on the homework, if you're not sure about your work, you can always take the derivative of the quantity and then show that that quantity is the same as the integrand inside your integral. In this question, we have the integral of, let's see, x cubed times 1 minus x squared to power 3 halves dx. Well, how do we use the substitution method here? What substitution helps us to do the calculation a little bit easier? Since we have a quantity inside parentheses and it has exponent 3 over 2, let us take u to be 1 minus x squared. Then du is equal to minus 2x dx. Or dx can be written as du divided by minus 2x. So let us simplify this as much as we can. We have the integral of x cubed, then this guy becomes u to power 3 halves, and dx is du divided by minus 2x. So if you simplify this integral, this becomes x squared u to power 3 halves, and then you have du divided by minus 2. So please note that I cancel out x with one of the exponent here. That's how you end up with x squared. But now you have an integral that has x and u in it. What should I do now? If I take a look at my u sub here, x squared can be written as 1 minus u. So I'm going to use this and simplify x squared into 1 minus u. So my integral is now becomes the integral of 1 minus u times u to power 3 halves du divided by negative 2. Well, it makes it much more easier to calculate this integral. Why is that? Because this guy is negative a half integral of 1 minus u to power 3 halves du. I'm going to distribute u to power 3 halves into parentheses. This becomes negative a half integral of u to power 3 halves minus u to power 1 times u to power 3 halves du. Very good. So how do you find this integral now? Well, this is equal to negative a half, the integral of u to power 3 halves minus u to power, if you take common denominator between these two exponents, because they have the same base, you're adding the exponents together. This guy becomes 5 over 2, and then du. This is a familiar integral. We saw this integral before. These are all using, let me erase this part of the board. So I can move it up a little bit. And show you the next step in the process. Remember that if you have the integral of u to power n du, it is u to n plus 1 divided by n plus 1 plus constant of integration. So let us calculate the integral of u to power 3 halves first. This becomes u to power 3 halves plus 1 divided by 3 halves plus 1 plus c, or u to power 5 over 2 over 5 over 2 plus c, or you get 2/5 u to power 5 over 2 plus c. So far, I can simplify my integral to -1/2 and 2 times u to power 5 over 2 divided by 5. This is your first integral here. The second integral with the same process, with the same argument, can be written as -1/2, and you have a negative sign, so you get +1/2, and u to power 5 divided by 2. The integral of u to power 5 over 2 du is equal to, so if you add 1, you get 7 divided by 2, 2 over 7, u to power 7 over 2 plus c. This is your second integral. So times 2 over 7, u to power 7 over 2 plus constant of integration. Okay, we can simplify this further. We can get rid of 2 and 2. 2 and 2, your first integral is negative u to power 5 over 2 divided by 5. And the second integral is u to power 7 over 2 divided by 7 plus constant of integration. But what is u? Remember that your u is 1 minus x squared. We have to substitute this guy back here. This is equal to negative square root of, well, my u is 1 minus x squared to power 5 divided by 5 plus square root of 1 minus x squared to power 7 divided by 7 plus c. And again, remember that if you have u to power 5 over 2, it's by definition is the square root of u to power 5. Or if you have u to power m over n, it is the nth root of u to power n from algebra. So the method of substitution helped us to calculate this integral a little bit easier. But we had more algebra to include in the solution of this integral.